Teaching is twice learning. So today, together, let's learn the combining capacity of the atoms, how do they form chemical bonds, that is the chemical bonding together. Hello, this is Preeti Chhabra and welcome to Learning Never Stops. Today's video is on valency and chemical bonding. Now, to come to the topic valency, let's see what are valence shells. What is a valence shell? The outermost shell of the atom is called the valence shell. In the last video, we had discussed about the electronic configuration. There we had seen how the electrons are distributed in different shells according to their atomic number. Now, the last shell in which the electrons are accommodated of a particular atom is the valence shell of the atom. What are valence electrons? The number of electrons present in the valence shell, that is in the last orbit, are the valence electrons. These valence electrons, they determine the valency. Valence electrons determine the valency. Now, if we have the knowledge of valency, this knowledge can be applied to understand how molecules are formed, how the molecules of elements are formed, how the molecules of compounds are formed. What are elements of compounds? What are molecules of elements? What are molecules of compounds? They are nothing but when the atoms of the same elements they combine together, they form molecules of the element. For example, oxygen atom combining with another oxygen atom to form one molecule of oxygen. This is the molecule of an element. Molecule of compound, when the atoms of two different elements combine together to form a molecule, for example water. Here hydrogen atom and oxygen atom, these are the atoms of two different elements. They combine together to form one molecule of water. This molecule is the molecule of compound. So if we know what is valency, or according to the valency of the atom, this knowledge can be applied to find out how molecules are formed. Now, atoms combine with one another according to their combining capacity known as valency. What is valency? It is the combining capacity of an atom to combine with other elements. Now, what is the capacity of the atom? Capacity of the atom is determined by the valence electrons. First of all, the question arises, why do the atoms combine? They combine to gain stability. Every element, every atom needs to become stable. Every atom needs to gain the state of stability. But only a few elements, atoms of only a few elements, those of the inert gases, are stable in nature. Rest of the elements, they either need to gain some electrons to attain that state of stability, or they need to lose some electrons from their valence shell to gain the state of stability. Now, elements with same number of valence electrons in their valence shell show similar property. The electrons, the elements which have same number of electrons in the valence shell. For example, say lithium. It has one electron in its valence shell as its electronic configuration is 2 and 1. Sodium, its electronic configuration is 2, 8 and 1. Okay. All the elements which have same number of valence electrons in their valence shell, they show similar properties. For example, all the elements with valence electrons 1 or 2 or 3, all these have metallic properties. All the elements which have 1, 2 or 3 electrons in their valence shells, they are metals. Fine. And the elements which have 4, 5, 6 or 7 electrons in their valence shell, they are non-metals. They are non-metallic in nature. Now, combining capacity means the electrons can be gained. They can be gained by the atom to become stable. They can also be, that means electrons can also be lost from the atom, from the valence shell for the stability, and they can even be shared. Now, how will we decide whether the atoms will lose electrons or will they gain electrons, or the atoms will share electrons? If there are 1, 2 or 3 valence electrons in an atom, such type of atoms will always lose electrons to complete their octet. Suppose we talk about lithium, then lithium has, this is the lithium atom with its nucleus, then this is the first orbit, and in the second orbit it has 1 electron because lithium has atomic number 3. So 2 and 1, 3. It has 3 electrons and 3 protons. Protons sit inside the nucleus. Since number of electrons is always equal to the number of protons and the atom is neutral in nature, so in lithium we have 3 protons and 3 electrons. But this is not the stable state of the atom. It either needs to complete its octet or needs to complete its duplet. That means it must attain the configuration of its closest inert gas configuration of its nearest inert gas. Here lithium can either gain 7 electrons and attain stability. If it gains 7 electrons, it will have 8 electrons in the outermost shell and will gain stability. Fine. But in that case, it will have only, proton number does not change, so it will have only 3 protons in the nucleus and will have 8 in the outermost shell and 2 in the inner shell. That means 10 electrons. Energy level wise, it is not possible for 3 protons to hold 10 electrons. So what will lithium do? Rather than gaining 7 electrons, it will give away this 1 electron. If it gives away 1 electron, lithium is left with only single shell with 2 electrons in it, and this is a duplet state, making this atom stable. But now what has happened to the proton and electron numbers? Proton number was 3 and it is still 3, but electron number was 3 initially when the atom was neutral. Now proton number remains the same, but electron number has reduced to 2 because it has lost 1 electron. So what, there will be some charge develop on the atom. Fine. What charge would it develop? Positive or negative? How will we see? Now 3 protons, that means 3 positive charge. Now it has 2. When it was having 3 positive charge and 3 negative charge, the atom was neutral. Now positive charge remains the same, that is 3 positive charge, but negative charges, how much negative charge is there? 2 negative charge. So extra 1 positive charge is there. So lithium will have 1 positive charge in it. So it will be a lithium ion with a positive charge on it. Now the ions which lose electron or the ions which gain a positive charge are called cations. Sodium is another example of a cation. If it gains stability by losing electron, it will become a cation. How? Lithium, just like lithium, sodium will also give away this extra electron, because to become stable either it will have to accept 7 electrons or it can give away this one electron, and then it will be left with the configuration of 2 and 8, with 8 in its outermost shell, and making the atom will become stable. Fine. So it is energy level wise, it is much easier for losing one electron rather than taking 7 electrons. So number of protons was 11, that means positive charge 11, and number of electrons initially when the atom was neutral, it was 11, but now when it will give away this electron, now how many electrons would be left? If one is gone, then 10 electrons, that means 10 negative charge would be there and 11 positive charge. So overall 1 extra positive charge will be there in the sodium ion. So we write Na plus. Okay, if it is plus, that means it is a cation. Now all the metals, when they become ions, when they become stable, they form cations, because metals have all the elements which have 1, 2 or 3 electrons in their outermost shell. They give away those 1, 2 or 3 respectively electrons to become stable. Now there is also possibility to gain electrons and become stable. That is the case when the outermost shell has 5, 6 or even 7 electrons in their outermost shell. If you look into some examples, we can say, suppose oxygen. What is the atomic number of oxygen? It is 8. What is its electronic configuration? 2 and 6. So 6 is the valence. With 6, it has 6 valence electrons. This is the outermost shell, this is the valence shell, and number of electrons in the valence shell is valence electron, that is 6 in this case. So it can either give away these 6 electrons and leave and it will be left with 2 electrons, and can also show stability by the duplet rule. But energy wise again it is impossible. With 2 positive charges, with 8 positive charges and only 2 negative charges. If it gives away 6 electrons, it will be left with only 2 negative charges. With 8 positive charges to hold, energy wise it is impossible. So it will be better to gain 2 electrons. If it gains 2 electrons, it will have 8 electrons in its valence shell. It has 6, it will gain 2 to become stable. Fine. In that case, what will happen? It has 2 and 6 electronic configuration. It needs 2 electrons to become stable. What will happen? 8 protons and 8 electrons were there at that time. The atom was stable. Now proton number will remain the same, but electron number will change to 10. So it will have 10 negative charge with 8 positive charge. If it gains electrons to become stable, if it takes 2 electrons, it will have 2 extra negative charge, because if it is taking electrons, that means it is taking 2 extra negative charges. Now what will be the ion? O2 minus. Okay, this is an anion. This is an anion. So this ways the valency is decided, the combining capacity is decided. The valence electrons, I told you, it determines the valency. How it determines the valency? If the valence electrons are 1, 2 or 3, that means if the outermost shell of an atom has 1 electron, it will give away that 1 electron. If it has 2 electrons or 3 electrons, it will give away those 2 or 3 electrons in its valence shell and will become stable. Okay, but if the valence electrons are 5, 6, 7 or even 4, what will happen? It will not give away. Energy wise it is not possible to give away those many electrons. Rather what it will do, that particular atom will gain those many number of electrons which are required. If it is 5, if the valence electrons are 5, that means 3 more electrons are required, so its valency would be 3. That atom would be electronegative in nature. Fine. If the valence electrons are 6, that means it will gain 2 electrons to complete its octet, to gain stability. Okay, so in that case its valency would be 2. How? It has 6 electrons, it has to gain 2 electrons, 2 is its valency. So this valency would be again electronegative because it is taking electrons and the negative charge is being increased. If it has 7 electrons in the valence shell, it will not give away those 7 electrons. It would take 1 electron. So valency would be 1 because it is taking that 1 electron. Fine. Here also the valency would be electronegative. So valency can be either 1, 2 or 3. If it loses 1 electron, or it loses 2 electrons, or it loses 3 electrons to complete the octet, that means it will gain extra positive charge and will become cation. If it gains electrons, in that case also it will either gain 3 electrons or will gain 2 electrons or will gain 1 electron and will become anion, because while gaining it will gain the negative charge, so it will become negative in nature. Okay, so valence electrons may be 5, 6, 7, but valency is not 5, 6, 7. Valency, if the valence electrons are 5, valency would be 3, because valence electron 5 means 3 are needed. Valence electron 6, that means 2 are needed. Valence electrons 7 means 1 is needed. And if there are 8 electrons in the valence shell, that means it is already stable, it is inert, it is an inert gas, and it is chemically not reactive. So atoms which have incomplete octet are the only atoms which are chemically reactive, which are chemically active. Fine. These atoms which are chemically active, they combine with one another, they combine with the atoms of different elements, or of the same elements also they may combine to form molecules of compounds or molecules of elements. When they combine together, they form chemical bonds. This is the second part of the topic. It is the force of attraction between two atoms that bind them together. During this bonding, when the two atoms are being bound together, what happens? Some redistribution of electrons take place. What is redistribution of electron? What I just now told you. If suppose, I'll tell you with an example. If suppose I'm talking about sodium is 2, 8 and 1, so it needs to give away this 1 electron. So there must be some other atom which is in need of this 1 electron. Say for example chlorine. What is the configuration of chlorine? It's 2, 8 and 7. So what will happen? This will give away 1 electron and this is in need of that electron. It will take this electron. So a bond would be formed between Na and Cl, whereby Na will develop a positive charge and will become stable, and Cl will have a negative charge and will also become stable. So the bond between these two is the chemical bond. It is the force of attraction which will bind these two atoms together so that both of them gain stability, which is the whole and sole purpose of the electrons to take part in the chemical reactions. The whole thing which is being done over here, the giving away of electron, the accepting of electron, the formation of the molecules, everything is being done here because all the atoms need to attain the state of stability. Now chemical bonding, we have seen chemical bonds may be of two types. Electrovalent bond, okay, or covalent bond. Now what is electrovalent bond and what is covalent bond? This chemical bonding can be of electrovalent type or a covalent bonding it may be. Electrovalent, some electric charge is being developed. Like here you can say these types of ions, when they are formed, where one is gaining and where one is losing and the other one is gaining the electrons, and both of them have developed certain charge on them, ions are being formed here. That type of bonding is the electrovalent bonding. In covalent, some thing is being shared. That means if the two atoms which are involved in the formation of bond in such a manner where both the atoms they need to gain electrons, both the atoms they need electrons to complete their octet. In that case, what do? They just share their electrons in the valence shell to attain stability. How? For example, say we'll take two examples, one from the atom of the same element and one from the atom of other element. Suppose talking about oxygen. Oxygen forms O2 molecule. Only the non-metals, only the atoms which need to take electrons from the which need to take electrons to attain stability can form covalent bonds. The metals which have extra electrons, they already have extra electrons. Why will they share their electron? They don't need any extra electron from any other element. Instead, they need to give away the electron which it has in its valence shell to attain stability. So it will never share. It will only form electrovalent compound. But non-metals, or the metals which have, or the elements which have 5, 6 or 7 or even 4 electrons in their outermost shell, these are the elements which will always gain or share electrons. They can either gain from these metals or can even share. Mutual sharing can also be there. So O2, it needs 2 electrons. It has 6 valence electrons. So what will it do? One oxygen molecule with 1, 2, 3, 4, 5 and 6, this is called the electron dot structure. What is electron dot structure? In the electron dot structure, we show, that means electron dot structure includes the symbol of the element with the dots which represent, these dots, they represent the electrons in the valence shell. Okay, whenever we write the electron dot structure of the element, what do? The electron dot structure includes the symbol of the element and it is surrounded by the dots, and these dots represent the electrons which are present only in the outermost orbit. The valence electrons are only depicted by the dots in an electron dot structure. So suppose this is the electron dot structure of one oxygen molecule, one oxygen atom, but here there are 2 oxygen atoms. So another oxygen atom is there with 6 electrons. How will they pair? They'll pair like this. They will form bonds between them. How is the chemical bond represented? It is represented by a line like this. Like here, I have written like this. This is represented by a short line. And one bond has 2 electrons. It has a pair of electrons where each electron is given by the atom which is involved in forming the bond. Like here oxygen, this is one bond. So it has 2 electrons, 1 electron from this atom of the oxygen and 1 electron from this atom of the oxygen. Here also it will form one more bond. Why 2 bonds? Because oxygen needs 2 electrons. So here it has gained 1 electron from this atom and 1 more is needed. It will it will share. This also needs 2 electrons. So they are together making bonds by mutually sharing their electrons, and like this they complete their octet. They become stable, and so we get one molecule of oxygen. This is the molecule of element. How the molecule of compound is formed? For example, say water. Fine. This is oxygen. It needs 2 electrons. So it will take 1 electron from one hydrogen, whereby I am showing hydrogen electron with a cross, and oxygen electron with a dot. Still one more is needed, so like this. So like this covalent bond is formed. So what is the difference between electrovalent bond and covalent bond? Electrovalent bond is where anions and cations are developed, ions are formed. Covalent bonding is where sharing takes place, mutual sharing between the electrons of two different atoms take place. Now we'll try to understand the electrovalent bonding and the covalent bonding with the help of certain structures, with the help of the examples. For electrovalent bonding, let us look into MgCl2 structure. Magnesium, fine. What is the electronic configuration of magnesium? Its atomic number is 12. So what is its electronic configuration? It is 8 and 2. What will it do? It will give away these 2 electrons. Now chlorine, there are how many atoms of chlorine? 2 atoms. What is the electronic configuration of chlorine? Its atomic number is 17. So its configuration is 2, 8 and 7. Now here magnesium needs to give away 2 electrons, but chlorine has 7 electrons, so it will take only 1 electron. Since it can take only 1 electron, so 2 chlorine atoms are required. So here magnesium 1 electron it will give to 1 chlorine atom, and its other electron would be given to another chlorine atom, and the structure will become MgCl2. We'll get one molecule of MgCl2. Suppose this is Mg nucleus, then these are the 2 electrons in the magnesium atom. So it has 8 electrons in the second shell. These are the 8 electrons in the second shell, and the outermost shell has 2 electrons. Fine. Chlorine, there would be 2 chlorine atoms required to take these 2 electrons from the magnesium. Suppose this is chlorine with 2 electrons in the first shell, then 8 electrons, and then in the outermost shell it has 7 electrons, 6 and 7. We require one more chlorine atom. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6 and 7. Fine. Now this is going to combine with these 2. How? 1 electron will be given to one atom, the other electron would be given to another atom, leaving magnesium with only 2 shells and giving these 2 electrons to 2 different chlorine atoms. Together we will get MgCl2 structure. Fine. Let us take one more example. Say suppose calcium oxide. Here calcium, it is 2, 8, 8 and 2. It needs to give away these 2 electrons. Now I will show this with the electron dot structure. Oxygen, oxygen is 2 and 6. It needs 2 electrons, so this will give away 2 electrons and this will accept 2 electrons. And the electron dot structure, I told you, only the symbol is written and the outermost electrons, the electrons in the outermost shell are depicted by the dots. And in case of oxygen, this is oxygen atom with the electrons in the outermost shell would be depicted. It will give away these 2 electrons to the same oxygen atom. This will become calcium 2 plus, this will become oxygen 2 minus. So both these cancelled, plus and minus charge, so we will get calcium oxide molecule. Okay, this way electrovalent bonding is done. You can show electrovalent bonding like this, the structures. Now covalent bond can be single bonds, they can be double bond, they can even be triple bond. Okay, there are many examples of single bond like water, H2O. These are single bonds. Single bonds means one pair of electron combining between two atoms, forming one bond. One pair of electron means two electrons. Pair of electrons means two electrons. Two electrons, one from each atom. Here also single bond, one atom, one electron from oxygen atom and one atom electron from hydrogen atom. So two single bonds are being formed. Other examples of single bond, I'll show you this side. Other examples of single bond can be methane. It is CH4. 4 single bonds are formed. This is carbon combining with hydrogen. One electron from hydrogen and one electron from carbon in this bond. Likewise, one carbon and another atom from the hydrogen in this bond. Likewise, one atom and one atom in this here also. So 4 single bonds are formed in methane. So methane is also an example of single bond. 4 bonds are there, but every bond is single bond. So this is not an example where you can show that more than triple bonds are also formed. When the bonds, more than one bond is formed between the same two atoms, then we can say there are the bonds are double bond, or when there are 3 bonds formed between the same two atoms, then they form triple bonds. But when 2 different atoms are involved to form single bonds, that molecule is a single bond molecule. So methane is an example of single covalent bond. Like carbon tetrachloride, this is carbon, again Cl, it needs 1 electron. It will get those 4 electrons from it will share those 4 electrons. Carbon also needs 4, chlorine also needs 1. So 4 carbon atoms will combine its 4 electrons. One carbon atom will combine its 4 electrons with 4 different chlorine atoms to give 1 tetrachloride molecule. Fine. This is also an example of single bond. Double bond examples can be like O2. It's a very common example of a double bond. How? Oxygen atom, electron dot structure if I depict, then it has 6 electrons. How many electrons does it need? 2. If it combines with one another oxygen atom, these 2 bonds can be shared, and these 2 electrons and these 2 electrons can be shared. So 2 bonds are being formed between these 2 oxygen atoms. This is also an oxygen atom, this is also an oxygen atom. When these 2 bonds are formed between the same atoms, this bond is also formed between these 2 atoms, this bond is also formed between these 2 atoms. This type of bonding is called double bonding. Triple bonding, we can take the example of nitrogen. Nitrogen, it has 5 valence electrons. That means it needs 3 more electrons. So it will share these 3 electrons with other nitrogen atoms. So 2 atoms these 2 same atoms, they share all the 3 electrons to gain stability, to form chemical bond, to form the covalent bond. So nitrogen forms triple bond. Nitrogen is molecule is an example of triple covalent bonding. Now the structure of the covalent bond can be shown as, suppose if you are talking about chlorine molecule, after combination what will be the structure? The structure would be, suppose this is the chlorine atom, I'll only show the valence shell. 1 2 3 4 5 6 and 7. The 7th electron, while showing the combined state, will not write here. We will share, to show the sharing, we'll write the 7th electron here, and the 7th electron of the other atom will also be written between this overlapping 3 4 5 6. Okay, this is the 7th one, but this shows that this seventh one of electron of this atom is being shared by this atom, and this seventh electron of this chlorine atom is being shared by this chlorine atom. So together they form one molecule of chlorine. This is how we write the structure of covalent bonds. You can write the structure of all the covalent compounds or the covalent bonds like this. You just have to show the number of electrons which are being shared. You just have to show those numbers overlapping. So in a nutshell, if we discuss what we have studied today, we had discussed what is valency. For that we have learned what is valence shell, what are valence electrons. Then we came to know what is valency, what is a combining capacity. Why do the atoms combine? They combine to become stable, and during the combination they form some bonds, that is the chemical bonding. This chemical bonding can be formed by electrovalent bond, or it can also be formed by covalent bonding. Electrovalent bonding is formed between a metal and a non-metal, whereby one atom needs to give away electron and the other atom takes those electrons, and ions are developed. And in the case of covalent bonding, the electrons are shared, they are mutually shared between two non-metals. This covalent bonding can be single bond, double bond, or triple bond. We have seen the electron dot structure, we have seen the structure of the covalent bond, we have also discussed the structure of the electrovalent bond. So I end my video here today. Hope to see you in my next video. Till then, stay safe, stay home. See you. Bye bye.